For question 2, the liver produces a liquid which is added directly to the partly digested food in the small intestine. This liquid is bile. Yeah, so bile is produced by the liver, but it's stored in the gallbladder. That's why the gallbladder is called a bladder, yeah, because a bladder is a storage organ. Maybe try to think of another storage organ that you know that has a very similar name. Okay, so in the gallbladder, it's bile that is stored after its production in the liver. And this bile, it contains bile salts, and these salts act as an emulsifier. Yeah, so an emulsifier is needed because if you want to digest lipids, so I should have said it's needed for lipid digestion, because if you want to digest lipids, well, first you must really mix it with the digestive juices, and that's difficult because, as you know, mixing lipids with water is like mixing oil and vinegar. If you're making a vinaigrette, for example, they don't mix well. So what you can do is add molecules that act like a little bridge between the two. Molecules that on one end mix well with lipid, and on the other end they mix well with the aqueous solution. So that is called an emulsifier, and the bile salts, they do just that. So what they do is they enable the lipids to be mixed really well with the aqueous solution, with a watery solution that contains the lipase. And the lipase, of course, is the enzyme that digests lipids. And this greatly increases the surface area for the lipase to act on. Yeah, so if we imagine, sorry, I'm just going to try and draw something here. Yeah, so if we imagine a big fat droplet. Sorry, that's coming out really weird because I'm looking at what I'm doing through my phone. So let's say that this is a fat droplet, and the lipase molecules, they're around here. So they can't mix well with this fat droplet. Yeah, they can only attack the fat droplet from the outside, and that's rather difficult. Okay, so what the emulsifiers do, yeah, so these are the bile salts. What they do is they make tiny fat droplets, and you can imagine I'd have to draw many more to represent this whole fat drop there. Yeah, so basically the fat is broken down into lots and lots of tiny fat droplets. Now imagine what that does to the surface area. Yeah, so the surface area here seems relatively big, but if we add up all these surface areas of every tiny droplet here, the surface area is now much bigger, which means that the lipase can now attack from all different sides, meaning that the lipase is going to be ever more efficient than it was before the addition of the bile salts. All right, okay, so I hope that makes sense.